The power of nature was on stark display with Taiwan's recent 7.5 magnitude earthquake. Earthquakes are a sobering reminder of the immense forces at play in our world. While the island nation boasts a strong tradition of earthquake-resistant building, this event underscores the need for even more innovative and inspiring home designs. Welcome to AI Studio. This journey about the imaginary concept for something in the future from an artificial intelligence perspective, and how to the AI says. Let's do we explore the art of beauty within. A recent earthquake in a world island nation, known for its robust earthquake-resistant building practices, has highlighted the need for even more advanced and inspiring approaches to home construction. Here, we explore some concepts that could revolutionize how we build safe and secure dwellings in earthquake-prone areas. This event serves as a catalyst to explore innovative concepts that can revolutionize how we build safe and secure dwellings in areas prone to earthquakes. While existing earthquake-resistant building methods have proven effective, the recent earthquake compels us to push the boundaries of design. We need to explore new materials and techniques that can absorb and disperse seismic energy more efficiently. Imagine homes that sway with the tremors, like reeds in a strong wind, instead of succumbing to the force. The future of earthquake-resistant housing might lie in a simple yet ingenious, prefabricated, interlocking timber frames. These homes would be constructed from lightweight wooden components designed to fit together like puzzle pieces. Taiwan's earthquake serves as a wake-up call, urging us to dream up earthquake-resistant homes that are not just safe havens, but inspiring places to live. The beauty of this house lies in its flexibility. Unlike rigid structures, these timber homes can sway and absorb the tremors of an earthquake. This innovative puzzle-like design helps dissipate the energy of the shaking, minimizing damage to the house and its occupants. By combining these ideas with cutting-edge technology and a focus on functionality and beauty, we can build a future where homes stand strong in the face of adversity. Another benefit of prefabricated timber frames is their lightweight nature. Traditional earthquake-resistant buildings can be quite heavy, which can put additional stress on the foundation during an earthquake. Lighter homes experience less force from the shaking, further enhancing their seismic resilience. Prefabricated timber frames offer a significant benefit in terms of construction speed and simplicity. The pre-made components can be quickly assembled on site, significantly reducing build times compared to traditional methods. This not only translates to faster move-in times for homeowners, but also facilitates faster reconstruction efforts in the aftermath of an earthquake. Earthquake-resistant building technology is often associated with large structures like skyscrapers. However, a promising concept called base isolation is making its way down to homes, offering a revolutionary approach to seismic safety. Imagine a house that sits on a special foundation, essentially isolated from the shaking ground. This is the essence of base isolation. By incorporating a series of bearings and pads between the foundation and the house itself, the system allows the home to move independently during an earthquake. The brilliance of base isolation and its ability to significantly reduce the stress placed on the house by an earthquake. As the ground shakes violently, the bearings and pads absorb the energy, essentially decoupling the house from the violent tremors. This innovative approach minimizes damage to the structure and protects its occupants. While traditional earthquake-resistant buildings are designed to withstand the shaking, occupants might still experience significant motion sickness. Base isolation systems offer a distinct advantage in this regard. By absorbing the shaking energy, the system creates a much calmer experience for those inside the home during an earthquake. The humble shipping container, a workhorse of global trade, might hold the key to the future of earthquake-resistant housing. These inherently strong steel structures offer a unique and promising approach to building safe and secure homes in earthquake-prone areas. Shipping containers are designed to withstand incredible loads, making them ideal candidates for earthquake-resistant construction. By stacking and bolting them together, builders can create robust structures capable of withstanding significant seismic activity. This approach leverages the existing strength of the containers, eliminating the need for complex and time-consuming construction techniques. One of the biggest advantages of using shipping containers for homes is their modular nature. The containers can be easily stacked and combined in various configurations to create homes of different sizes and layouts. This modularity allows for a high degree of customization, catering to the diverse needs and preferences of homeowners. Additionally, the prefabricated nature of the containers facilitates rapid construction, allowing families to move into their homes quicker. Repurposing used shipping containers for homes offers a sustainable advantage. It reduces the demand for virgin building materials and provides a new lease on life for these robust steel structures. By embracing earthquake-resistant shipping container homes, we can create safer living spaces while promoting environmental responsibility. The future of earthquake preparedness might extend beyond individual homes, envisioning entire neighborhoods designed for resilience. This concept centers around the creation of earthquake-resistant microgrid communities, where homes are interconnected in a localized power grid. Microgrids are self-contained energy systems capable of generating and distributing power. In earthquake-prone areas, these microgrids could be integrated within neighborhoods, allowing residents to generate their own electricity through solar panels, wind turbines, or other renewable sources. This localized power generation ensures some level of functionality, even if the main grid fails after an earthquake. The beauty of microgrid communities lies in their inherent collaboration. Homes with surplus power generation capacity can share it with neighboring houses, ensuring everyone has access to electricity for critical needs like communication, refrigeration, and lighting. This collaborative approach fosters a stronger sense of community and facilitates faster recovery efforts after a disaster. Microgrid communities offer a glimpse into a future where earthquakes disrupt lives less dramatically. By ensuring access to power, these neighborhoods can empower residents to recover more quickly and efficiently. Furthermore, the reliance on renewable energy sources promotes environmental sustainability, making microgrid communities a beacon of resilience and innovation. The recent earthquake serves as a powerful reminder of the ever-present threat of seismic activity. While safety remains paramount, this event compels us to push beyond simply building shelters. The future of earthquake-resistant homes lies in creating havens that are not just secure, but also inspiring places to live. The key lies in a harmonious marriage of functionality and aesthetics. That a concept for something stands as an enduring symbol of a testament to the perpetual curiosity that propels us towards an ever-unfolding future. Thank you for watching and see you again in our next video.